Hey everybody, my name is Michael Withrow. I'm a Senior Product Manager on the Azure Kubernetes service. I actually cover all the security features. It's obviously one of the biggest features that everybody talks about, so security, networking, et cetera, stuff like that. So what am I gonna talk about today? So as I kind of go through, I'm gonna actually cover everybody, what are we trying to do with security to make it easier for customers. I'm gonna talk about the strategy that we have in place that's gonna let you guys know where we're going from a feature perspective. One of the big complex things I'm gonna cover is what's the best practices for security with all the different capabilities that we have from a portfolio perspective. How do I bring them together to build my end-to-end security capabilities from a feature perspective? I'm also gonna open the pillar a little bit and talk about what are we planning to do, what capabilities are coming down the road. And then I'm gonna walk through two of our new features, has been alluded to, long-awaited workload identity, which we just announced last week at Ignite, which is our new evolution of formerly a pod identity, which gives you allows your Kubernetes clusters and your resources to access Azure-based resources. And then another net new feature called Image Cleaner, which I'll talk through a little bit as well. So what is our strategy? What are we going for from a capabilities point of view? Let me figure out why I didn't catch up. Hold on. Oh, interesting. Hold on. It is frozen. Hold on. Awesome. Hold on. Right when I got to the good stuff too, right? All right, hold on. Yes, resume slideshow.
If you can't make it work, Michael, you have to do an interpretive dance.
I will. Hold on. I'm almost there. No, it's stuck. Look. Yeah. All right, we're almost there. Anyway, while that's coming up, essentially, there we go. So what is our strategy? What are we doing from a feature perspective? All right. So as I kind of alluded to, we're essentially aiming to build an enterprise, end-to-end, Azure native story for container security, okay? So what does that really mean? So obviously when we look at end-to-end, it's not just about securing the cluster as you put your applications on top of AKS, but from build all the way through your application itself. So as you're building your application, how do I know what I'm building secure, that I'm pumping into the cluster? How do I know that the cluster that I'm dropping my application on is secure? How do I know the underlay that's running that cluster that is secure? And then how do I know that my application that's up and running, how do I know that that's running securely? If something happens, how do I know and how do I actually prevent it and actually build proactive-based security? These are all things that are top of mind from a security capability point of view. Most importantly, how do we do this natively out of the box? Heard from many, many customers, yes, I can deploy open source on top, I can deploy third party on top. I really want to use native-based capabilities. So does it pass muster? Is it there? Can I use it? These are all the key capabilities that we're trying to build out. So there's a lot of key capabilities that exist within Azure today that make that happen. Obviously, Azure AD, identity, policy, Microsoft Defender, so adapting, everybody's probably heard of Microsoft Defender for Container SKU. So that's a big one. And then obviously confidential compute. There's a lot of announcements we're doing across confidential compute. The big things that you look at from a functionality perspective is that obviously MDC is a SaaS-based solution. So if you look at a lot of the open source or a lot of the third party, all the automation you got to build in to deploy those components, maintain those components. Obviously with MDC, because it's a SaaS, it's essentially just there. So there's some added benefit from just having MDC as a base capability as long as we can get all the functionality right. Okay, and so obviously that allows us, not only that, but we own everything, right? So we build the integrations. We're working natively. So I'm constantly working across the entire Azure ecosystem with AKS as a first-party solution, making sure that all the different components are working together to build an entire end-to-end security story. Most importantly, from our perspective, we've done a lot of the work on the back end that probably a lot of customers don't know. So we have a back-end DevSecOps pipeline, which essentially secures everything, right? So we have our FedRAMP guidelines that essentially everything is patched within 30 days. We're doing all the automation to make sure everything's patched and available within 30 days. I'll talk about essentially how you consume that, how you make that easier as well. The key thing is that not only do we have a DevSecOps pipeline, but we're essentially building all the components that we use on AKS from source. So from the automated pipelines to the patch, build, deploy, for all those remediated images. Secondly, AKS, we are part of the Kubernetes disclosure. So obviously we get all the embargo content. So we go through and that gives us all, because we're plugged in, and not only do we get access to that, but we have developers plugged in all the way left from an upstream perspective. So we start the patching immediately. So when everything's ready to go, we are first to market for releasing those vulnerabilities and those remediations. And as long as everybody might be aware, we have MSRC as well. So for anything that happens, we have MSRC keeping everything honest. So if there's a cyber attack, there's a vulnerability for a customer cluster, for a customer resource, everything's pumped in through MSRC so we can start the remediation process. So now, going too fast, hold on, everything's slow. There we go. So what are best practices, right? What are the things that I need to think about? So you can see, essentially, I've kind of segmented everything out across the different areas that you'd be concerned about, whether it's the build environment, whether it's your registry, whether it's your cluster topology, the node itself, because remember, it is a resource you need to be accounted for, and then the application itself. So essentially, as you start out, obviously, I talked about Microsoft Defender for containers. The key thing from our perspective is we built Microsoft Defender for containers to plug into the entire ecosystem across from the build all the way through the application. So depending on, if you're using GitHub Actions, you're using ADO, think of Microsoft Defender as now from a SKU perspective, giving you static analysis capabilities. So I call that out. There's other things we're building out. So think of like secrets management, malware, detection, compliance assessment, enforcement, other things like that that we're building out as well. But now that we've got the base structure in place, now we start stacking in capabilities on top of that. On the registry side, think of as you're promoting your DevSecOps pipeline, you want to make sure that the images you're building are clean. Once you get to the registry, how do they make sure it doesn't drift? And so with that, obviously, Microsoft Defender for Container as well plugs into that registry, does static analysis on the content that sits in that registry, and then we're adding in signing capabilities. So we're doing a lot of work with our open source, and so you see the theme that we're talking about. We do a lot of contribution, especially on the security side, of building in an open source and then consuming it in AKS and making it a managed component. Signing is no different. We've been working on Notary V2, essentially, which brings it in, and we have an end-to-end solution that works, bridging together open source Notary, open source Ratify on the verification side, and then basically restricting the publication on AKS because it wasn't able to verify that signature. There's some work we're doing as well to kind of add in like more day 2 operations into Ratify. Once we have that, we're going to be announcing a public preview on the AKS side, so it's a fully managed add-on from an experience perspective. On the cluster side, there's obviously a lot there because we own the cluster. At the top, we always talk about AAD, right? So if everybody is aware, if you deploy a cluster, I can do an AZ AKS create. That essentially deploys a local cluster with Kubernetes RBAC enabled. There was a glitch that we had if you deployed through Terraform as an example. One of the older versions of Terraform would deploy just a local cluster without any RBAC as well. I'll talk about that here in a minute. But the idea, if you deploy a cluster, it's going to come with Kubernetes RBAC. Essentially what we're talking about is you do want to AAD enable that cluster, because when I AAD enable that cluster, I get all the AAD authentication, but I can do controlled access, I can do JIT access as an example. But then as I look on the RBAC side, there's an important feature set that we have as well. So we've been doing a lot of work for like auto cert rotation as an example. And then has everybody heard of like our VPN solution called connectivity? Does connectivity ring a bell? So we're working to move our tunnel solution off of OpenVPN and tunnel SSH over to connectivity. Well, all those features require RBAC as a base capability. So as you look at your cluster, is it RBAC enabled? We can light up all these different capabilities for you. So as a base level, if you're RBAC enabled, you get auto cert rotation, you get all the latest security features, and then obviously you get all the power of AAD as well. From there, obviously, on the identity side, we also have managed identity. I want to talk about that to level set as well. So we can do service principal, which works. We have about 18% of our clusters left that are doing service principal. Mainly, I think most customers doing that because they're doing cross-tenant, as an example. We have all the work in managed identity. The last remaining piece was that cross-tenant, but now we're working on another capability called federated identity. That really comes with our workload identity capability, which makes essentially managed identity OIDC enabled, which breaks the tenant barrier. So that'll be the last hurdle that we have, and so now everybody should go, and we'll actually move from managed identity over to federated identity as well. So really nobody should be using service principals. Azure policy we talked about. Obviously, George talked about that earlier as well. Not only do we have Azure policy, but the underpinning of Azure policy is actually OPA and Gatekeeper, right? So we make open source contributions, we add in capabilities, and then we move that into Azure policy. So not only do we have everything, we're actually doing the final work for mutation support. So we have that through our custom policy extension on top of Azure policy. So really anything you could do from an OPA or Gatekeeper perspective, you can do from an Azure policy perspective as well. And then lastly, we're adding in another capability which really ties into the notary solution and quarantine and other features we're building around external data source as well. So the idea is that you can have a policy do verification of state from somewhere else. So think of like trying to deploy an image, and on that deployment, you need to restrict it. Now the policy needs to query something else for state. So we have that now pinned inside of Gatekeeper, and now we're working to integrate that into Azure policy as well. So that will be one of the big hooks for us. So as we build the end-to-end story, think of Microsoft Defender as the attestation across the state, and then plugging in policy at each of the points to say, yes, I can promote that image up, or that image is not allowed to leave the registry, or whatever it might be, based off of that external data source. And then also as well, we have Microsoft Defender once again. If you look at it across each of the pieces, it is singly looking at the API. So if you're worried about somebody doing API transactions, that's essentially what the Defender is going to pick up for you as well. And then I talked about Image Cleaner. So the cool part about Image Cleaner is that everybody has purge capabilities. Now that we moved to Containerd, think of Image Cleaner as really just an automated schedulable purge capability. Right? So I'll talk about that a little bit more in depth, but this really goes now, if I have a whole bunch of images that are sent on my node, this is an automated process. I can keep my nodes clean, therefore removing that risk. We'd also talked about AKS 125. So why is this on here? We've added a lot of security capabilities into AKS 125. That's now in preview, but we're moving that to GA as well. And you'll start to see, we've kind of drawn the line in the sand, Ubuntu 2204, which is the 5.15 kernel, right? Mariner as a cause. Container Optimized OS, that's 5.15. That'll be coming with 125 as well, right? So a lot of these key capabilities that we're building will be tied to 125. On the node side, obviously we do a lot of work I kind of alluded to from a feature set perspective around securing the node. So how do I keep it up secure? So if I look across a lot of the customers, I get emails every single day, hey, we found this vulnerability on this node, we found this image, and essentially the first question I ask every single time, what version is your node image? Have you upgraded your node version? Right? Because remember, we are building, essentially every single week, we commit fixes for that particular VHD. More importantly, is it not just basically packing in that OS, but we also pump all the updated patched images and we cache them in the VHD as well. So it's not only important to update your OS and your node image, but keeping your Kubernetes version up to date as well, because we will pin patched versions to AKS versions, as an example. And so there's a lot of different ways you can do it. Some customers just do it themselves, but we're trying to make it easy, so now we have this auto upgrade SKU. So there's a couple of different auto upgrade SKUs that you can subscribe to, but the base one I've kind of talked about here is just the node image. So to make sure that you're running the latest node image, which not only makes sure that your OS that you're running is patched, but that OS is also consuming the latest patched images as well. Node authorization. So this is a big one as well. So think of this as really preventing north to west attack vectors. So I've got a 3-node cluster up, I've got an application. How do I know that someone didn't attack my node and try to attack the other nodes and the other pods on there? So node authorization is the key capability that we have there for that. It's really just restricting the capabilities that kubelet can do. By default, that is on in 124. So if you deploy a 124, 125, that'll be on by default, nothing for you to do. But if you're on a downgraded version, we have the ability for you to add that as well. Confidentiality. There's a lot of work we're doing in the confidential SKU space, right? So we own the OS, we own the work. We've been doing a lot of work with Intel and AMD to basically build encryption from basically the OS, the boot layer, all the way up through the OS layer and through the VHD as well. So there's a bunch of things coming as well. So if you really worry about trust and worry about the vendor and everything that we're doing, definitely leverage the confidential-based capabilities. On the application side, obviously bringing in Defender again as well. One of the big things that we were doing for Defender, if you probably remember our old SKU, what we've really done here is we've readapted this capability to now do true runtime defense capability. So by bringing in the Falco capabilities down in here, we're now actually doing runtime defense down at the kernel level. So now, the key thing that we're doing is adding in a series of capabilities. So think of like process level attacks, network attacks, storage level attacks. As an example, that's what this runtime sensor is essentially doing. So what we're doing is building it out twofold. I'll talk about that a little bit more as we go on. But it's not only building a runtime sensor, but then building drift controls for it, then building a network sensor, and stacking out the capabilities there. For secrets management, we actually have a couple of different ways to do this. We built out CSI Secret Store, which externalizes your secret. It's my recommended best practice as well. A lot of DevOps teams put the secrets in the cluster, which makes etcd an attack vector. We've now secured that with KMS, but it's just easier in a lot of ways to use CSI. That's why I kind of have an or there. We have two ways to do it depending on the way your business is built. But in my opinion, I'd rather you externalize your secret out in Vault. And then workload identity. Pod identity is about 3 years old, so this has been a gap for us for quite a while, so I'm working really hard to get this to GA. But now, and I'll talk about this a little bit more here in a second, but the idea is that workload identity is the path forward, and now it's the idea for how you would secure your tiered applications. You have a pod talking to a storage account, or whatever it might be. So obviously there's still quite a few things missing, right? So what's coming? What are we working on? So you can see there's a host of capabilities that we're building out in this semester. So when I look at this semester, it's the next four to 6 months, right, that we're building out. So on the build side, within Microsoft Defender, we're adding in image, secret scanning and malware scanning. This is a big ask from a lot of customers. Malware is probably one of the top asks that I get. So how do I know when I compile an image, compile a binary, that it doesn't have any malware in it? So Defender will be able to pick that up on build. On the registry side, I talked about right now, Notary works open source. We're doing all the back-end work to bring that to public preview, so it will be a managed add-on on AKS. It's really adding in all the day 2 operations capabilities to ratify, and we'll announce that as well. I just kind of go through vulnerability assessment of distroless images. Obviously, as you look across the ecosystem, there's many ways that a customer could deploy an image. It's making sure that the static analysis binary can actually scan anything. We announced, obviously, Ubuntu and Windows. Now we have Mariner as a image, making sure that Mariner can, if you build a application on Mariner, that it actually works. Distroless, Scratch, all that stuff, making sure that just works from a binary perspective. Quarantine as well. I've been talking about this one for a while, but I'll be glad this is coming out. So as you're looking at your pipeline, so think of, I build an image, I clean that image, I push it to the registry. Now it gets to the registry and it becomes contaminated. How do I know that, and what do I do with it? So quarantine is really putting a policy on push and pull to say, hey, look, on push, if it's dirty, block it. On pull, if it's dirty, block it, et cetera. So think of before it actually gets to the cluster, I can actually look at its state with that external data source capability and restrict that deployment. On the cluster side, about 6 months ago, I published our attestation for CIS for the cluster itself and for the underlying Ubuntu OS. So there's still a lot of work we're doing on the CIS front to be the most compliant because, once again, we're a PaaS service, so it's not really much you can do, but it's just our way of doing attestation, right, as an example. So I think on the CIS for Kubernetes, we failed 9 things. This semester, we're going to fix 5 of them, so we'll be down to 4 that we failed. Looking at everybody else, I'm not going to talk about anybody else, but we failed less than everybody else. Obviously, on the Ubuntu side, we failed quite a bit more, but we're also running 1804. Going to 2204, we're going to be at a lot cleaner state. So we're working on CIs for Windows. So we just started running the script, so we're actually going to be publishing this very soon. So if you do decide to deploy Server 2022, you will have at least the attestation for the state of that there as well. Making Image Cleaner GA, because obviously the cycle that we're rolling through from a feature perspective is that I know what most, especially for security capabilities, most customers go, great, it's in public preview, but I can't use it or consume it or make it a standard until it hits GA. So that's the main reason I published this on the timelines as well. So we'll be publishing or GAing Image Cleaner as well. And then I did talk about federated identity. So federated identity is a huge capability for us. Obviously, with secrets management, with the token management, with the essentially the service account token volume projection capability that we've now added into AKS, now we can do OIDC-based managed identity, right? So this goes from IMDS-based, now having IMDS as an attack vector, moving the identity off the node, right? So all the work we had to do before was we had to assign the identity to the node and basically pass rights and capabilities to it. So if I was able to compromise the node, I got all these different capabilities off of that. So now with federated identity, I move essentially the identity transactions out to AAD, and essentially all that Kubernetes is doing is just basically pulling the token. So that's going to be a big thing as well. So what we're going to be doing is moving all the identity capabilities within the cluster over to federated identity as well. So let's see, I talked about instance metadata. So we're going to be doing a lot of work to restrict instance metadata. This is something the other vendors do as well. That's just something we're going to close out. Custom CA trust. I don't know if anybody knows about this. This is one of the reasons I want to talk about it as well. We do have a way if you need to manage your certs for your cluster. So think if you need an application or your nodes to talk out to like a minimum firewall or a proxy or something like that on the edge of your cluster. Essentially, a lot of customers just say, hey, how do I manage that? Well, we built a feature called Custom CA Trust, which you basically deploy your cluster and you pass in which certificates you want the nodes to boot off of, right? So that feature is out. We're actually going to make that GA'd really soon. Another big one as well is air-gapped AKS. So depending on your level of trust that you have with the cluster, there's still quite a few pieces that, depending on where you're at from a configuration perspective, that there is, you look at like our AKS egress document, right? Where there's a couple of network calls have to call out over the public endpoint. And more importantly, what if I have Azure talking to Key Vault or Azure or AKS talking to ACR? How do I know that that's all talking over the private endpoints instead of publicly? Right? So air-gapped AKS is what brings that home. So every single transaction that cluster does, talking to all the other Azure resources, will all be over private endpoints. And so it's just a setting that you'll basically pass to the configuration. On by default, this is an interesting one, right? You can see there's a whole page of features, right? So what do I deploy? When do I deploy it? How do I know how to deploy it, right? So it's really complex. So what we're working towards is starting to turn a lot of these best practices on by default, right? And obviously the key point is if it's on by default, you can also elect to turn it off, right? But the whole premise of us turning it on by default is to make it easier for you to use, right? So we're going to be working on Azure Policy. We're going to be turning on AAD by default as an example. So all those clusters get managed, get AAD. We've already turned on Managed Identity by default as an example. So we're stepping through these best practices. So all you really have to do is an AZKS create, and you get all the best practices by default. And then risk-based prioritization by attack vector. So this is the big one as well, is if you look at threats and cyber attacks, how do I know what the state of my cluster, the state of my applications is? So that we're building into Microsoft Defender, so it's actually a view in Microsoft Defender. I'll probably be showing this at the next conference as well, but then I can actually see the risk that my application has within the cluster topology that is deployed in. Another big one, on the node side, we are now working on a kernel isolation capability. So it's not ready for public preview yet, but I'm actually announcing that on our blog post we're publishing tomorrow, so this is net new information for everybody. We're working on a kernel isolation capability. So everybody's aware in the Docker ecosystem that is a shared kernel, right? So this gives customers the ability to carve up that kernel that they have tied in. And obviously for us, this is foundational as we start to build up the stack. So think of CVM from a capability point of view, and then the kernel license down below. It allows us to do a lot of creative things up above, which I'll be announcing down the road as well. SSH. So one of the big pain points that everybody has is how do they manage SSH? Right? So I hear from every single enterprise is I have compliance requirements X, Y, or Z for my SSH configuration. So for the most part, we've said customers can do what they want. You can just do a policy and basically turn it off if you want. Now we're actually making it more managed so you have options. So it's really three-phased for us. So update SSH, this has been a big pain point. There's actually a long-standing AKS issue, which is about 18 months old, is, hey, look, I want to roll my SSH keys. How do I do that? So we're actually going to make a feature so that you can roll those keys as you desire. But more importantly, we're going to give you a feature if you want to just flat out disable SSH, you basically pass a flag and SSH is off. And then thirdly, another feature is AAD-enabled SSH. So the idea here is, yeah, I want to use SSH, but I want to be able to audit it. I want to be able to use AAD to audit it. We're going to AAD enable that SSH configuration, which will once again just be a feature flag. So Mariner obviously is a big one. So we just announced that in public preview. Obviously, we're already working through the GA feature sets, but this will be one of these SKU options that you can leverage. The big capability, if you look at Mariner, there's a lot of inherent benefit. One, it's a 5.15 kernel, but so is Ubuntu 22.04, right? So that was a big push for us to get off the 5.4 kernel that we're on over to 5.15. So that's big. But obviously, Ubuntu, we have to source with an external vendor for the patching of our OS. Now with Mariner, we own that. It's all in-house, right? And it's not as bloated as Ubuntu, right? It is literally a cause, meaning that we had an internal version of Mariner, but it had, say, 6,000 packages associated with it, right? The package repository still exists, but Mariner cause on AKS is a zero-sum OS. Well, it only has 147 packages. So it's very, very minimized, right? So there's a lot of work we're doing. There's blue-green scenarios that we're going to be enabling down the road. That'll be one of the GA feature sets that we work through. So think of like all the problems everybody has with the unintended upgrades of Ubuntu as an example. So if you look at the operational side, we're tackling a lot of that stuff with Mariner as well. So as we go onto the application side, there's work that we're doing right now to move to an agent structure. So if you look at MDC and how it does data collection, the key idea with runtime security is all about proactive security. So essentially what's happening when you deploy MDC on your cluster and then you start deploying applications into your cluster, MDC, or the first state, will start inventory. Right? In other words, it'll start to build a state of your applications, so now it knows what drift is, right? So we used to do that on the node itself, but we now know how to do that from an agentless-based perspective, query the API server, and it'll build that inventory, so now when the application drifts, we know exactly what that drift looks like, right? So think of like a dynamic-based firewall. And as I kind of alluded to, now that we've got a lot of the sensors working for runtime, because it's one thing to say you have runtime, but what does the runtime actually do, right? So you look at a lot of the third-party ecosystem capabilities that exist out there, not only are we building the sensors, but we're building the corresponding drift protection that exists. So think of as an example, in this scenario, I built an application to run Java. Well, now it tries to run a netcat or whatever process off of that, that is outside of the known transaction list, and the drift sensor will actually restrict that transaction while whitelisting the Java process that existed before. More importantly, with all of this stuff as well, as I alluded to, I've been building out all the CIS capabilities, but all they really exist as AKS docs, right? So you can see, hey, look, here's the 9 checks we failed in Kubernetes. Here's the checks we failed on Ubuntu. The next thing we're doing is actually porting this into MDC. So the end state that we're shooting for is I can go into my cluster and I can see the attestation state of my cluster and all my resources. And then I can go to MDC and see the attestation state for all my clusters. And then obviously there's the ARC scenario where I can go to all the environments, all that stuff like that as well. Another big one that's coming as well, if actually there's going to be a KubeCon session about this here tomorrow, I think. Is everybody aware of user namespaces? So the challenge here is that when you look at Docker in the ecosystem, essentially when I build a root container, they're all talking on the host network, right? Host network equals true. So if I compromise that, I just compromise the host, right? Because that container is running as host network equals true. So in order to mitigate this, we've actually, there's a KEP that we have against Kubernetes to implement for root containers the ability to leverage user namespace. And so now you can start to segment, because there's still some applications you write that will need to talk to the host network, but not all your root applications need to talk to the host network. So now you can start to segment your applications to reduce your attack vectors. Secret discovery is a big thing that we're doing as well. So I deploy an application. How did I specify the secrets in there? Am I passing in my credentials for my database right in my image? Or am I externalizing it out with an environment variable as an example? So all those best practices we'll have as well. And the big one, I know I get this question probably about 100 times a day. When is workload identity going GA? So this will be a Christmas present for everybody, is the date that we're shooting for. So by I'm hoping by 12/30, but probably like January 3rd is really when this will go GA. So I know a lot of customers ask about that. All right. So what is workload identity? So at the end of the day, this is kind of the data flow, and I'll talk through what the implementation looks like. So if anybody's used pod identity before, we've made a lot of enhancements for workload identity compared to pod identity. The big thing to really, if you look at it, is pod identity was IMDS based, and workload identity is OIDC based. So the idea is that by leveraging service account token volume projection and OIDC issuer capabilities within the cluster, now we're able to natively leverage Kubernetes capabilities to basically pass a token into the application so that the application can talk to external Azure resources. So in pod identity, we had to do some shimmying to basically build the node identity and then basically assign the application the node identity, right? So there was different attack vectors that existed there. But you can kind of see the flow here is that, hey, look, I do a request. Essentially, the application needs to access a resource. Essentially, now it basically asks Active Directory, hey, can I use this? Active Directory will verify with OpenID Connect. We have a discovery document we built on the back end, which will hold the certificate information. Once they have that, I'll check the trust, verify the trust, and then essentially, if everything's good, essentially Azure AD will issue a token for the pod to leverage to now use and talk to those external Azure resources. The key thing is there's now no identity transactions required anywhere on the node. Right? And so I'll go through a little bit of this, but this is kind of, I got in front of my slides, but this is the kind of the flow that you kind of go through. So now, to kind of go through the demo, see if I can kick this off as well. There we go. So let me fast forward a little bit. Is it thinking about it? All right, while this is loading, I'll give this a second to load. But because it's a managed add-on, essentially all we've done is really, there's two key capabilities that you'll do. I think it's playing, hold on, I'll let it play. And then I'll talk through it. But the idea is that it's a feature flag to enable workload identity. That's easy enough, right? But the other key dependency we have is enabling the OIDC issuer. We just GA'd that feature set as well, and which is really setting the OIDC issuer URL on that cluster itself. That's the key point for how AAD knows what to trust, is based off of that issuer URL. That will be a default capability, so going down the road, you will not have to enable the OIDC issuer, but that is a key dependency for workload identity today. And it does not look like it's playing. I thought I tested this before. Sorry about that. I'm having all kinds of logistical challenges. All right, I'll just talk through it. But the key idea is that there's a simple scenario that we have, and I'll share the document with everybody. So we have a tutorial that's on our AKS docs. The key thing is that once you set in the workload identity, all you're really doing is building a managed identity in the portal, and then you go through and build a federated identity off of the managed identity. Okay, so just like you're used to today, you build that managed identity, you go in the portal, you build a managed identity. Now you're stacking in a federated identity that can be leveraged. Then you go into the cluster itself, you create a service account, and you bind that federated identity to the service account. Then you create a trust off of that configuration. You tell AAD, hey, this configuration is trusted, which is basically the client ID of that federated identity, the service account, and the OIDC issuer URL. And say, hey, look, if you get a request with this topology, it's trusted, and you can create an access token off of that for the cluster itself. And then we have a tutorial from end to end, so of an application that needs to leverage a key vault. That was the demo that I kind of ran through. Pretty simple to kind of go through, but if you think about for anything you need to leverage, most customers use it for storage accounts, for key vault is pretty the key scenarios. That's the reason we documented it out that way. Image cleaner, see if my demo works here as well. Image cleaner is the next one. To be clear, really think of this as just like an automated purge engine that I can schedule, right? And that's the key thing. And so we used to give guidance before, said, hey, look, obviously when it was Docker, it was pretty easy, but now you're just running a crit cuddle purge that you can run in the environment, and then we wrap that with an engine so it's automated out. And the key thing is, from a differentiation point of view, is that this is really targeted at your images that sit on your node that are not attached to running applications. So it's very common from a pipeline perspective to everybody build the environment. So think of building version 1, version 2, version 3, version 4. But what happens is, essentially, after a while, your images stack up in the environment. How many customers actually go through and clean that stuff out? Not many, right? And then so, like, I'll give you an example internally in Microsoft. What would happen is all the service teams say, hey, I've got a report of 8,000 vulnerabilities. And all the vulnerabilities were off of legacy images that were just sitting there stale on the node. So that was the initial inception for why we should build this feature. So essentially, I basically pushed this back to upstream and said, hey, we need this feature. Upstream built it, leveraged it out for open source, and then we just built it as a managed add-on. The key thing is it's tied in with a schedule. So think of it as, hey, look, I want this to run every 24 hours, once a week, as an example. And so what it will do is actually go through when it runs, it will actually go through and query all the nodes. So say I have a 100-node cluster with 50,000 images running on there as an example. It will go through and pull that list. It will generate a list and will disqualify anything out that is attached or running. But then you could also say, hey, look, maybe you as a customer, I want some of them cached there. So you can exclude those as well. I'll set that, and then essentially the engine will go through and actually curate everything that's left on that list. And you can rinse that out however you need to from an automation-based perspective. Looking at us from internally, that's going to just get rid of 50 or 60% of the risk just by cleaning those stale images out. Let's see if this demo runs as well. Yeah, there was running in the background. But this is kind of a walkthrough of it. So this is one of my peer PMs. She put this demo together for me. But there's two key capabilities. There's obviously you'll build image cleaner on the cluster, which is one key capability. And as you can see here, this is really just tackling the stale images. And so there's a couple of ways we can classify what's a stale image. It's really just anything that's not attached to a running application. But there's other cool things that were coming as well. Now we're going to start to go through, say, hey, look, I just want to purge out all these stale images that have a high or critical vulnerability on them. I could tag that and purge those out as well, or I could just run a purge and just purge everything out, have a lot of different things. And obviously, this is predicated off the open source eraser. Everything that we do, I can't stress this enough, every single thing that we do is based off of open source. We contribute to open source, we consume it, we make it a managed add-on, and we roll through. So every single one of the capabilities is based off of those open source contributions. So you'll see in the cluster, there's a topology of applications. A lot of things that we do, workload identity is no different in that regard. Essentially has a controller and a webhook, right? So a lot of things that we do. So what's really nice about workload identity, I'll talk about that in a minute as kind of go through. But essentially, you can see here it's collecting all the unused images. And that's the key point. And then essentially the scanner now goes through, details the point, and then essentially generates a list, which triggers the eraser container to remove, which is just running a purge, and purges all those images out. And then you have a historical list that you can reference after the fact. So this is just another one of those governance things to reduce the risk vector that exists in your environment. Hopefully that's making sense. Like I said, the big thing that we're kind of working through is really just, as we look across all the different features that we're building out, we understand what the attack vectors are, and we're strategically going after those attack vectors, and basically building it from a product portfolio perspective. I can't tell you how many customers I talk to say, hey, look, we're using this, and we're mixing this together, and most customers have either some big third-party solution they're paying to have on top, or a hodgepodge of solution they're kind of bringing together to bring it home. What we're really looking to is you basically hit a button and the whole SKU deploys, and then I just basically set my configuration and I'm done. Obviously, there's a little bit of work to do, but that's where we're going. Any questions from there? I know it was a lot of content. Anybody in here care about security? All right, how are we doing on time? But yeah, like I said, just to kind of round it up, there's a lot of things that we're doing. So a lot of things that are there. So I'm going to be publishing a blog tomorrow for the KubeCon blog. We just published our blog last week as well for Ignite. A lot of key capabilities that we're releasing out. And like I said, each feature is very strategically focused on its specific attack vectors from a security perspective. All right. Thanks, everybody.